Hi there everybody, today we're going to look at arc lengths and areas of sectors. Okay, before you kind of do this, if you do not know how to work out the circumference or you do not know how to work out the area of a circle, then please look at that lesson first. So the lesson involving circles before you kind of come across to do this one, because I'm going to use those kind of skills today. Now obviously I'm going to mention them anyway, but I suggest you look at those videos first before kind of doing this one. So here we go. So an arc, by definition, first of all, is part of a circumference, or is a portion of a circumference. Hence, you need to know the circumference first. But the full circumference is made up of 360 degrees, if you think about a full circle. And you can work out an arc length by dividing the circumference by 360 and then multiply the degrees in the sector. All right, this will make more sense when we look at an example, which we're going to do now. So calculate the length of the arc in the shape. So the arc is basically this distance around here. All right, and that's all it's asked for at this point. It wants the arc of this particular shape. All right. Well, I know that the radius is 6. Okay, and the circumference is pi times diameter. Well, the diameter is 2 lots of the radius. Okay, so all we've got currently is the radius, and I want the diameter, which is the whole distance across it, which is going to be 12. All right, so the circumference would be pi times 12. Okay, so pi times, so that would be the whole circle if we had the whole circle. But of course, we don't have the whole circle. We only have 125 degrees out of 360 degrees of the circle. All right, so circumference is 37.7. So the arc length is you're gonna take your 37.7, divide it by 360. That's going to give you 1 degree's worth of the circumference, and then times it by the angle that you currently actually have, 125. So what you're actually doing is you're working out the fraction of the circumference, a portion of the circumference. So you divide it by 360 and then times it by the angle you've currently got, and that's going to give you this distance over here, which is 13. All right, does that make sense? All right, so there you go. So that's how you work out the arc length. All right, so you take the circumference in entirety, so you need to know how to work out the circumference first of all. You divide it by 360, which is 1 degree, and then times it by whichever angle you've currently got. All right, let's look at sectors, because the process of sectors is pretty much the same, but rather than actually working out the distance on the outside, we're talking about an area. So I need to know the area of a circle first of all. So the area of a sector is a portion of a full circle, and the full circle is made up of 360 degrees. And we're going to do pretty much the same thing we just did for an arc length, but this time with the area. All right, so calculate with the area of this shape. Well, again, so what we're after is the area of the full circle. So I need to know what the formula is for area of a full circle, which is pi times radius squared. Well, we know the radius is 8. So the full circle would be pi times 8 squared, which would be pi times 64, which is this, 201.0619. So that's the area of the full circle. But of course, we don't have a full circle. We only have a fraction of the circle. So we're going to divide it by 360, which is what it says over here, and then multiply the degrees in the sector. So divide by 360 and times by 131, and that's going to give us the area of that sector. All right, so without doing anything any further into this, you need to know what obviously the area of a circle is and the circumference of a circle. They're the two key parts of it. And then because you're working out only a fraction of it, then you're going to divide by 360 and times by the angle that you've currently got. All right, so that's arcs and sectors that you need to do. So please go to maths-school.co.uk, link is at the bottom, and have a bit of a practice on some of those kind of questions. All right, thanks for listening.